Beyond the warm breath of our sun, beyond the fragile veil of planets and comets bound in orbit, lies a silence so absolute it seems eternal. It is here, in the unlit reaches between the stars, that wanderers are born, shattered fragments of alien worlds, exiled into the abyss, and one of them has come here. Astronomers call it 3I Atlas, the third interstellar object ever witnessed by human eyes. It did not belong to our solar system. It carried no invitation. It appeared as though it had slipped between the curtains of infinity, a stranger from a distant star, speeding across the void with a velocity that mocked the sun's dominion. This was no ordinary comet, no native stone of Earth's sky. Its path was hyperbolic, a trajectory carved not by our sun, but by another light long since lost to distance. It was a fragment from another cradle of planets, a shard from a system where other skies once glowed, larger than those that came before. ʻOumuamua's enigmatic shard, Borisov's ghostly comet Atlas, loomed with a bulk that spoke of destruction on planetary terms. If such a wanderer ever collided with a world, its violence would dwarf any myth humanity has written of fire from the heavens. Yet its terror lies not only in size, but in meaning. For if 3 have already been seen in the short span of human searching, how many more drift unseen through the darkness? How many silent messengers, each carrying the memory of another star, glide past the Earth unnoticed? The question remains, lingering like an echo in the cosmic dark. What truth does this alien fragment whisper about the terrifying vastness beyond our sun? On the slopes of Hawaii's volcanic mountains, where the thin air sharpens starlight, 2 instruments keep nightly watch over the sky. Their name is Humble Atlas, the Asteroid Terrestrial Impact Last Alert System. Their mission, urgent but earthly, to scan the heavens for objects that might one day strike our fragile world. But on the night of December 2019, one of these telescopes caught a glimmer that was not destined for Earth. Instead, it carried the signature of something far stranger. The object at first appeared faint, another tiny mark drifting across the CCD sensors, a wandering speck against the background of eternity. Its designation would come later, 3I Atlas, the third interstellar object ever recorded. But in those first hours, it was only a puzzle, coordinates and numbers in a digital log, a piece of sky in motion, the legacy of Pan-stars and ʻOumuamua. Discovery of Atlas's interstellar wanderer did not come from nowhere. Only 2 years earlier, humanity's eyes had been forced open by another telescope, another Hawaiian sentinel, Pan-stars, the Panoramic Survey Telescope and Rapid Response System. In October 2017, Pan-stars noticed a needle-shaped body racing past the sun. Astronomers gave it a name that felt as alien as its origin, ʻOumuamua, the Scout in Hawaiian. Its path was hyperbolic, fleeing the solar system with no intent to return. Humanity realized, for the first time in its history, that a messenger from another star had crossed our celestial neighborhood. The shock of ʻOumuamua reshaped astronomy. It proved interstellar visitors were not just theoretical, they were real. They were here, and they could be seen. And with proof came hunger. Scientists turned their eyes to the skies with sharpened vigilance, awaiting the next dot, the arrival of ATLAs. That next visitor came quietly. On December 28, 2019, the Atlas telescope, at Mauna Loa Observatory recorded a faint object in the sky. Its official designation would begin as C 2019 Y4, flagged initially as a possible comet. Atlas, designed to find faint, fast-moving hazards, had stumbled upon something far larger in implication. Night after night, follow-up observations sharpened the picture. The orbit refused to obey the familiar patterns of solar system bodies. Its trajectory bent outward, not inward, toward infinity rather than return. Its speed was greater than the sun could hold. It was, unmistakably, interstellar. And with that realization, humanity counted its third visitor from the void, 3I Atlas. The astronomers behind the watch. Behind every detection is a human presence, often unseen, seated in the quiet glow of monitors while the dome above drinks starlight. The Atlas project was led by John Tonry, an astronomer at the University of Hawaii, and supported by a team of researchers and engineers. Their design was pragmatic, to 0.5-meter telescopes, one on Mauna Loa and the other on Helioclase, sweeping the entire visible sky every 2 nights. Their purpose was defensorily warning for Earth against rogue asteroids. Yet, in the act of protecting a planet, they became chroniclers of the galaxy's deeper story. When Atlas flagged C 2019 Y4, it was initially mistaken for a typical comet. Only through calculation, through the slow unraveling of its orbit, did its true nature emerge. The astronomers were not prepared for a discovery of interstellar scale, but the cosmos does not wait for preparation. It arrives, indifferent, on its own timetable. A data log of eternity. The first records of Atlas were nothing poeticros of data. Coordinates in right ascension and declination, timestamps in universal time, magnitudes measuring brightness against the black. Yet within those numbers lay a truth that would echo across astronomy. Plotting its path revealed the impossible. The eccentricity of its orbit was greater than 1, a mathematical signature that no native comet could bear. This was not a fragment bound to the sun. It was a traveler merely passing through. The excitement spread quietly at first. Mails exchanged, orbital calculations cross-checked, whispers among teams accustomed to the monotony of nightly sky scans. But as the orbit solidified, the realization dawned. Another fragment of another star had wandered into our reach, a messenger from elsewhere. The discovery of 3I Atlas carried a weight beyond scientific classification. It meant the silence between stars was not empty. It meant other planetary systems, distant and unseen, were shedding fragments that reached us. Unlike ʻOumuamua's silent shard or Borisov's cometary plume, Atlas was large. Estimates suggested a body hundreds of meters across, perhaps larger. Before it began to fragment under the heat of the sun, its size alone inspired awe and a kind of fear. For in its presence, humanity glimpsed the scale of celestial wanderers that might pass unnoticed until too late. Yet what stirred astronomers most was not fear, but humility. Here was a piece of another system's history, a relic of alien processes. A world we would never know had nonetheless brushed against ours, leaving only a trace of light before vanishing forever. The philosophical undercurrent every detection, every faint trace across a telescope's sensor, is a dialogue with the cosmos. Most nights, the answers are predictable. Asteroids catalogued, comets confirmed, stars mapped. But once, in a rare while, the sky whispers something greater. ʻOumuamua was the first whisper. Borisov was the second, a comet with unmistakably interstellar chemistry. And now, Atlas had spoken the third word in this dialogue, reminding humanity that the galaxy is not distant, but intertwined. The act of discovery is fragile mere photons striking silicon, faint traces of light traveling for millions of years before colliding with human instruments. Yet, in those collisions lies revelation. They are whispers across eternity, fragile threads binding our world to the infinite expanse beyond suspense of the unknown. The reality of 3I Atlas settled in. One truth overshadowed all others. Time was short. Interstellar visitors do not linger. They arrive with immense velocity, sweep past the sun in fleeting arcs, and vanish back into the night. Astronomers scrambled to gather every observation possible. Instruments across the world turned their eyes toward it, from small observatories to space-based detectors. Each photon recorded was precious, a clue to composition, origin, and fate. But the deeper one looked, the more the mystery grew. Atlas, like its predecessors, refused to fit cleanly into categories. Its brightness varied strangely. Its structure seemed unstable. Soon, it began to disintegrate before the sun, denying scientists the chance for long study, and with its fading came frustration. A messenger had arrived, but it would not stay to tell its story. Closing reflection: the moment of discovery is always fleeting. For astronomers, it is the instant between ordinary and extraordinary, when numbers in a log transform into the footprint of something cosmic. With 3I Atlas, that moment carried both awe and sorrow. It was awe at the scale of what had been found, a fragment from another star system, larger and more violent than its predecessors. And it was sorrow at the brevity of its visit. The refusal of the universe to grant more than a passing glance. Yet even in its passing, Atlas left a mark. It proved once again that the void between stars is alive with travelers. It reminded humanity that our solar system is not isolated, but open, vulnerable, and connected to a galactic sea of fragments. And perhaps most profoundly, it whispered a truth science is only beginning to confront, that in every shard of stone crossing interstellar space, there lies the memory of another world. Worlds unseen, perhaps destroyed, perhaps still thriving under alien suns, but carried to us in the silence of the night sky. The discovery of 3I Atlas was not only an astronomical event, it was a philosophical one. For in its brief crossing, humanity caught another whisper across eternity, a fleeting voice that asked us to consider how many others pass unseen, and what stories do they carry in their silent flight. The solar system is a sanctuary bound by gravity, a closed dance of planets, comets, and asteroids, tethered to the sun's invisible pull. Every body here, from the smallest dust grain to the largest planet, shares one truth: it is held captive. Their orbits may be wide, their journeys long, but all must eventually bow to the sun's dominion. Yet there are exceptions, rare haunting intrusions. Objects whose trajectories are not circles or ellipses, but open-ended arcs, paths that cut through our system once and never again. These are the hallmarks of the interstellar hyperbolic trajectories, velocities so great that no gravity here can ever reclaim them. And so it was with 3I Atlas. The geometry of the unbound astronomer's plot, orbits not in poetry but in mathematics. The shape of a path reveals its origin. A circle means a perfect binding, a closed loop. An ellipse marks the ordinary course of planets and comets drawn out, but still loyal to the sun. A parabola is rare, a fragile boundary between capture and escape, but an orbit with an eccentricity greater than 1, that is the unmistakable sign of a visitor from beyond. It does not return, it does not linger. It is a line through our cosmic home, beginning and ending in interstellar night. 3 IATLAS carried precisely such a signature. Its eccentricity measured greater than 1, its velocity at perihelion racing beyond the limits of solar capture. Even before its full path was mapped, the numbers announced what the eye could not. This was a stranger in the system, born under another star. The path of Atlas entered our solar system from the direction of the constellation Ursa Major, a faint emissary approaching from the galactic background. As it fell toward the sun, its speed climbed tens of kilometers per second, a velocity beyond even the swiftest of comets born here. Its orbit bent in a curve, looping past the inner system before flinging outward once more. Astronomers traced its trajectory backward, as if rewinding a film. The path extended beyond the sun's influence into the interstellar medium, pointing toward no single star but toward the vast stellar plains beyond. Unlike the planets, which repeat their dance endlessly, Atlas had no rhythm here. Its journey was a crossing, not a cycle. Its future inevitable. Exile back to the galactic void. A family of strangers SLS was not the first. It was the third known to human science, following in the wake of ʻOumuamua, each with its own character, its own enigma. 1I ʻOumuamua, discovered in 2017, was the first revelation. Long and needle-shaped, it tumbled silently through space, showing no cometary tail, no release of gas, only a mysterious, non-gravitational acceleration. It left behind more questions than answers. 2I Borisov, found in 2019 by amateur astronomer Gennady Borisov, was different. It was unambiguous, a true comet with a glowing coma and tail, indistinguishable in chemistry from the comets of our own system. Its interstellar origin was written only in its speed and trajectory. Then came 3 IATLAS. Discovered in December 2019, it was larger, brighter, and in time revealed a tragic fate: fragmentation near the sun, unlike ʻOumuamua, which slipped away intact, or Borisov, which glowed like a ghostly comet. ATLAS disintegrated before its story could be fully told. Together, they formed a pattern. 3 interstellar visitors in just a handful of years. Once, the idea of witnessing even one seemed impossible. Now, the sky revealed them with unsettling frequency. The sign of exilic interstellar object is more than stone or ice. It is a fragment of another star's story. Somewhere, light years away, under skies unseen by human eyes, these bodies were formed. Perhaps they were comets circling young suns, asteroids shattered in planetary collisions, or remnants of worlds destroyed in stellar upheavals. Something tore them free gravitational encounters with giant planets. the chaos of unstable orbits, or the cataclysm of supernova. Cast adrift, they wandered the interstellar dark for millions, even billions of years, before chance steered them into our domain. They arrive as exiles, stripped of context, carrying only silence and trajectory. Yet in their exile lies meaning. They are messengers, proof that planetary systems across the galaxy breathe and evolve just as ours does. The comparison of velocities, ʻOumuamua, sped through at nearly 87 kilometers per second relative to Earth's orbit. Borisov, slower but still unbound, traveled at around 32 kilometers per second. ATLAS matched and exceeded these speeds. A bullet from interstellar night. These velocities dwarf anything humanity can yet achieve. Even our fastest spacecraft Voyager, racing outward at 17 kilometers per second crawl, by comparison. The interstellar exiles remind us that while our machines struggle to reach the stars, fragments of the stars come to us. Bearing the speed of galactic wanderings, the solar system as crossroads in these passages. The solar system is revealed not as an isolated island, but as a crossroads of the galaxy. Invisible highways of debris crisscross the interstellar medium, and from time to time, they intersect with the sun's small domain, what we see Borisov at Lesar, but the rare few bright enough to be noticed. Simulations suggest billions more pass silently, unseen, between the stars. Perhaps even now, another interstellar wanderer arcs through the outer darkness. Beyond the range of telescopes, its trajectory indifferent to our awareness. The exile's reflection there is a haunting symmetry in these objects. Each is an outcast, yet together they tell a collective story. They remind us that planetary systems are fragile, that stability is not guaranteed, that what is born in the warmth of a star may end cast into the cold between suns. Their presence is unsettling because it is personal. If other systems can lose their fragments so easily, then so too can ours. Perhaps one day, fragments of Earth will be scattered into the Milky Way. Exiles of a world once alive, crossing alien skies as uninvited strangers in this way. 31ATLAS is not just a visitor, but a mirror. It reflects the destiny of all systems, including our own, that in cosmic time, even planets may fall to ruin, and their remnants wander as whispers of what once was. Closing reflection 3, Atlas. Moved through the solar system like a ghost, here and gone in the span of months, too swift to capture, too vast to ignore. Its orbit, hyperbolic and unbound, marked it forever as alien. Its trajectory, fleeting and final, told us it would never return. But in its brief passage, it joined ʻOumuamua and Borisov in reshaping humanity's view of the sky. No longer could the solar system be seen as isolated. No longer could the stars remain distant abstractions. Their fragments are already here, passing us in silence, testifying to a galaxy alive with motion and upheaval. Each one is a story untold, a relic of alien skies, a wanderer whose exile makes it eternal. And in their passing, they remind us of a truth as beautiful as it is terrifying. The universe is not quiet, it is restless, and its strangers move among us, carrying whispers of worlds we will never see. For most of human history, the night sky seemed eternal and unchanging. The stars were fixed, the planets circled with quiet precision, and comets, though feared as omens, were still recognized as children of the sun, bound to its invisible leash. Astronomy grew from this certainty that the solar system was an enclosed theater, its actors rehearsing the same ancient roles, night after night, century after century. But in 2017, that stage was breached. ʻOumuamua arrived a sliver from beyond, hurtling through the sun's domain and leaving as quickly as it came. With it came a profound realization. The solar system was not sealed. The void between the stars was not empty. Foreign messengers could and did intrude. For centuries, astronomers had imagined such wanderers, fragments flung from alien worlds. Equations hinted at their existence. Probability whispered they must be out there. Yet theory and reality are separated by an abyss. And until that October night in 2017, none had been seen. ʻOumuamua shattered that silence. Borisov followed in 2019, and scarcely a year later, 3.1 appeared, larger, brighter, and more fragile than the rest. 3 interstellar objects in just a few years. The shock was not only scientific, it was existential. The end of isolation before 2017. Models of the galaxy had been cautious. Some astronomers suggested that interstellar objects would be rare, their detection unlikely in a single human lifetime. The emptiness between stars seemed vast. The ejection of planetary fragments, a theoretical curiosity, not an observable fact. ʻOumuamua changed that overnight. Suddenly, the improbable became present, undeniable. Then came Borisov, erasing any notion of coincidence. And when Atlas was found, the pattern was unmistakable. The implications were profound. The solar system was not a fortress in space. It was a crossroads, a place through which the debris of other worlds passed regularly, unseen until now. This realization broke the long-held illusion of cosmic solitude. Humanity was no longer studying a closed system. Instead, Earth and its companions were revealed to be immersed in a galactic current, a river of exiles flowing from other suns. The density question: why did these discoveries send shockwaves through science? Because the frequency implied numbers far greater than expected. If 3 interstellar objects were detected within only a handful of years, then the galaxy must be filled with them, teeming with fragments from alien systems. Statistical models were quickly re-examined. Based on ʻOumuamua alone, astronomers estimated that for every cubic parsec of space, trillions of such bodies might exist. That means within a sphere the size of Earth's orbit around the Sun, there could be thousands silently passing through at any given time, most too faint to see. This was no trickle-it was an ocean, a vast sea of alien debris drifting endlessly between stars. The thought was unsettling, for if the galaxy contains such countless exiles, then planetary systems across the Milky Way are not stable havens. They are violent places where gravity hurls fragments outward, scattering the ruins of worlds across interstellar space. The universe is not a quiet sanctuary. It is restless, turbulent, and filled with wreckage, a cosmic traffic of strangers. The sudden realization of frequency posed another terrifying truth. The solar system is constantly crossed by foreign messengers. At any moment, Objects from other stars may be passing unseen, brushing through the Kuiper belt, slipping past the giant planets, or even threading through the inner system. Most are small pebbles of cosmic drift, invisible to telescopes. But some, like ATLAS, are vast mountain-sized travelers, moving with speeds no gravity here can restrain. Their scale dwarfs human imagination. Should one collide with Earth, the consequences would rival the greatest extinctions in history. Though the risk is low, the awareness itself unsettles. For centuries, humanity saw cosmic impacts as threats from within asteroids and comets born of the sun. But now another layer of danger has emerged. Objects not of this system, unpredictable, uncharted, arriving without warning. The shock lay not only in numbers, but in vulnerability. The solar system is open, porous, and fragile. Its borders are not walls, but thresholds. Old models, shattered before 2017, models of interstellar object density were grounded in the belief that only rare fragments could escape their home systems. Planetary formation was thought to be efficient, with most material either incorporated into planets or left in stable belts. ʻOumuamua, Borisov, and Atlas forced a rewrite. If these wanderers are common, then planetary systems must eject material frequently, perhaps constantly. Gas giants, with their immense gravity, act as slingshots, hurling comets and asteroids into the void. Starbirth regions, chaotic and violent, scatter their fragments like sparks from a fire. The Milky Way, once imagined as a serene collection of stars, is instead a galaxy in turmoil. Planets are born, collide, and die. Their debris is not lost but flung outward, populating the interstellar night with trillions of fragments. In this vision, our solar system is not special, not isolated. It is part of a galactic ecosystem of creation and destruction. The visitors we see, ʻOumuamua, Borisov, Atlas, are evidence, silent witnesses of this hidden violence. The human reaction for astronomers. The discoveries were exhilarating but disorienting. The timeline of science had been compressed. What once seemed impossible to witness in a lifetime was unfolding within mere years. The dream of studying interstellar objects was no longer hypothetical. It was happening now, but excitement was shadowed by frustration. These visitors were fleeting, too fast for detailed study. ʻOumuamua left before instruments could probe its mysteries. Borisov, though better observed, still fled within months. Atlas, the most promising in size, fragmented before its secrets could be uncovered. It was as if the cosmos were teasing humanity, offering glimpses, then withdrawing them, leaving behind more questions than answers. A mirror to the galaxy, the shock of Atlas was not only that it existed, but what it implied about the nature of the galaxy itself. Each interstellar visitor is a fragment of an alien story. And if such stories are so numerous, then the Milky Way is not composed merely of stars and planets. It is composed of their ruins as well. This shifts perspective. When we look at the night sky, we do not only see stars burning quietly. We must also imagine the debris fields of countless worlds drifting unseen. The galaxy is not just a cradle of creation. It is a graveyard of fragments, a scattering of remnants that speak of instability, violence, and loss. And yet, there is wonder within the terror. For among this debris may lie the seeds of life itself. Some astronomers speculate that interstellar objects may carry organic molecules across the galaxy, seeding distant worlds. The wreckage of one system may become the genesis of another. Thus, what seems destructive may also be creative. The same current that scatters ruins may carry possibilities, spreading the ingredients of life through the Milky Way. Closing reflection. The discovery of 3I Atlas sent ripples far beyond data and observation. It forced humanity to confront the truth that the solar system is not an island, but a crossroads of galactic debris. It shattered the illusion of isolation, revealing a reality in which foreign messengers constantly cross our skies. It challenged old models, suggesting that the galaxy is restless, filled with exiles from stars unseen. It revealed a cosmos where violence and creation intertwine, where fragments of shattered worlds drift eternally, carrying whispers of alien histories. And in the quiet of that realization lies both terror and awe. Terror, because the scale of interstellar debris is unimaginable, and its consequences could be catastrophic. Awe, because each fragment is a story, a shard of another system, another sun, another possibility of life. The shockwaves of 3I Atlas were not confined to science. They reached deeper into philosophy, into the way humanity perceives its place in the cosmos. The solar system is not alone. It never was. The strangers have always been here, crossing in silence, unseen until now. With every detection, the galaxy speaks a little louder, and the message is clear. We are part of a universe, alive with motion, exile, and exchange. A universe where nothing is still, and where even the stones of alien worlds may one day find their way to our sky. The universe reveals itself not only through light, but through silence, through the unannounced arrival of objects that slip across the sun's dominion and vanish again into the abyss. Among these 3I, Atlas stood apart, where ʻOumuamua had been small and elusive, and Borisov, a comet of modest proportions. Atlas was vast, a body whose very dimensions forced a reckoning. It was not just another messenger from beyond. It was a reminder of scale, of size and power so immense that the mind falters in its attempt to imagine consequences larger than those that came before. When astronomers measured the faint glow of 8, they recognized immediately that this visitor was not like ʻOumuamua. The Hawaiian scout of 2017 had been slender and dim, barely 100 meters in length, a fragment that might have gone unnoticed had the survey telescopes been less vigilant. Borisov, the comet that followed, was larger, perhaps a kilometer wide, its dusty coma spreading its presence across the sky. But Atlas was different. Early observations suggested a body several hundred meters to nearly a kilometer in size, perhaps even larger before it fragmented. It carried the bulk of a mountain, a frozen citadel torn from an alien system and hurled into the interstellar dark. To comprehend such a scale is to place Earth in perspective. A body hundreds of meters across, moving at tens of kilometers per second, contains an energy release that defies imagination. Should such an object strike Earth, it would unleash devastation beyond any weapon humanity has conceived. The knowledge was sobering. Atlas was not only a stranger, it was a potential catastrophe, a reminder of what interstellar debris could mean if fate aligned differently. The energy of a cosmic bullet velocity is the true language of interstellar objects. Bound comets drift at speeds of a few kilometers per second, their paths gentle curves within the sun's leash. But interstellar wanderers are different. Their velocities are not inherited from the sun's gravity, but carried from the depths of the galaxy itself. ʻOumuamua swept through at 87 kilometers per second. Relative to Earth, Borisov followed at around 32 kilometers per second. Atlas, though its precise figures varied with fragmentation, likely approached in a similar range tens of kilometers per second, unyielding to any pole the solar system could offer. To imagine this is to imagine a bullet of planetary scale, moving not at the speed of sound, not at the speed of artillery, but at the relentless pace of galactic drift. At 30 kilometers per second, a mass of several 100 million tons carries energy comparable to millions of nuclear detonations. At larger estimates, the numbers climb further into destruction capable of reshaping continents. The Earth has faced impacts before the Chicxulub asteroid, 65 million years ago, which ended the age of the dinosaurs, was roughly 10 kilometers wide. Atlas was smaller, but its interstellar velocity magnified its power. A strike from such a body would not end a species, but it could erase a city, ignite global shockwaves, or plunge climates into chaos. Scale as existential, but the terror of ATLAs lies not only in physics, it lies in meaning. This was a fragment from another system. Its size was not random. It was a relic of processes beyond our sun, a shard of planetary violence elsewhere. Somewhere, light years away, another star had given birth to planets, comets, and asteroids. Somewhere, gravitational encounters had torn them apart, casting pieces outward into exile. Atlas was one of those pieces. Its scale was evidence of planetary catastrophe, worlds colliding, belts destabilizing, stars shedding their children into the abyss. It told a story that ours might one day tell, that planetary systems are not permanent, but fragile, subject to forces that can scatter their very bones across the galaxy. In Atlas, scale became existential. It was not just the size of the object itself, but the implication that the galaxy is filled with the ruins of other worlds, drifting through the night, carrying silent testimonies of destruction. If Earth stood in its path, what if fate had drawn Atlas differently? What if its path had intersected Earth, not in empty space, but directly with the planet itself? The scenario chills the imagination. A body of several hundred meters, moving at interstellar velocity, would strike with energy measured not in billions, but in hundreds of billions of tons of TNT. The blast would dwarf the largest nuclear weapon ever tested. A crater, kilometers wide, would scar the Earth, ejecting dust high into the stratosphere, shrouding skies in twilight. If it fell in an ocean, waves of inconceivable height would ripple outward, striking coasts across entire hemispheres. If it fell upon land, cities would be vaporized, forests flattened, the atmosphere ignited with five and stot. And yet, worse than the event itself would be its indifference. The galaxy would not pause. The stars would not notice. One fragment among trillions, colliding with one planet among billions, would change nothing in the cosmic ledger. For Earth, it would be catastrophe. For the universe, it would be silence. Such is the terrifying scale of interstellar objects. They are not enemies, not predators. They are indifferent bullets, fired long ago by processes no longer remembered. They cross our path not with intent, but with chance. Yet, chance is enough. Comparison to familiar impact risks humanity has long feared asteroid impacts. Telescopes track near-Earth objects, and surveys map thousands of potential hazards. But those are familiar threats, born of our own sun's debris, predictable in their orbits. Detectable long before collision, Atlas revealed another truth. There are threats we cannot predict. Interstellar objects do not follow the same rules. They do not orbit the sun. They arrive without warning, appearing from deep space with velocities too great to track in advance. ʻOumuamua was only detected after it had passed the sun and was leaving. Borisov was caught earlier, but still offered little time for preparation. Atlas, larger and more dangerous, reminded astronomers that our surveys are fragile, our awareness limited. The danger is not imminent probabilities remain low, but the possibility is real. And in that possibility lies unease. For while humanity gazes upward with curiosity, the galaxy may yet deliver reminders of its indifference. The terror of unseen numbers, the scale of Atlas, was terrifying enough. But more terrifying still was the implication of numbers. If 3 interstellar objects were observed in just a handful of years, then countless more must exist. For every one detected, thousands pass unseen, too faint, too small, or too distant to be captured by telescopes. Among them must be others the size of mountains, others the size of cities, perhaps even others the size of planets ejected from unstable systems, wandering as rogue worlds in eternal exile. The galaxy, then, is not merely a landscape of stars. It is a minefield of fragments, strewn across light years, crossing paths in silence. Earth, small and fragile, moves through this field unaware, shielded only by luck and distance. The terrifying scale is not just Atlas itself. It is the knowledge that Atlas was not unique, but one among an ocean of silent travelers. Philosophical reflection: what does such scale mean for humanity? On one level, it is humbling. It reminds us that Earth is not central, not shielded, not secure. We drift in a galaxy filled with strangers, each one capable of rewriting history in a single collision. On another level, it is profound. For each fragment is a story. Each is a relic of creation and destruction far away, carrying with it the memory of another system's fate. Atlas was not simply a rock. It was a page torn from an alien history book, a record of events we will never witness but can still infer. And in this way, the terrifying scale becomes more than physical. It becomes existential. It forces reflection on fragility of worlds, of systems, of civilizations. It forces recognition that survival itself is a matter of chance within a universe that scatters its ruins freely. Yet, within terror lies connection. For if fragments from other systems reach us, then perhaps fragments of ours reach them. Perhaps Earth, too, has already sent its silent emissaries, shards of rock ejected by ancient impacts, carrying with them molecules of life. Perhaps, somewhere, another world looks at its sky and sees the silent passage of a stone from our own system, a messenger of Earth. Thus, the terrifying scale is not only destructive, it is unifying. It reveals the galaxy as a place of exchange, not of communication, but of fragments, a place where systems are not isolated, but connected through the scattering of their bones. Closing reflection 3I ATLAS reminded humanity of scale, of size, of energy, of fragility. Larger than ʻOumuamua, more threatening than Borisov, it stood as evidence that the galaxy is filled not with peace, but with debris. Its mass and velocity spoke of catastrophe, of the possibility that any system, even ours, may one day scatter its fragments into the void. Yet its presence was also a message. It told of the fragility of planetary systems, of the violence that shapes them, and of the currents that connect them. It whispered that Earth is not alone, not in company, but in vulnerability. To look at Atlas is to see more than stone. It is to see a mirror of fate, a reminder that the scale of the universe is not measured in stars alone, but in the silent ruins of worlds that drift between them. The terrifying scale is both physical and existential. It is the size of the object, the energy of its motion, the destruction it could bring. But it is also the meaning it carries, that, in a universe of such violence, fragility and connection are inseparable. Atlas has long since vanished, fragmented and gone. But the memory remains. The image of a mountain-sized shard racing through the solar system, leaving behind a question that lingers still. How many more are out there, and when will the next arrive? When 3IATLAS first appeared in the field of view of Hawaii's survey telescopes, it was little more than a faint smudge of light, a whisper against the black, the kind of trace that, without careful attention, might vanish into the noise of a detector. Yet in that faintness lay the signature of something extraordinary. Astronomers turned their eyes and instruments toward it, hungry for detail. They wanted to know what this traveler was made of, how it reflected sunlight, and most importantly, what story it might tell about the system that had cast it out. But the cosmos rarely surrenders its secrets easily. The challenge of the Phaeton-like, the planets or the bright comets that grace the night sky. Interstellar visitors are fleeting and dim. Their surfaces are small, their journeys vast, and by the time they cross our solar system, they are often already dissolving into darkness. For 3I Atlas, the difficulty was doubled. Though larger than ʻOumuamua and brighter than Borisov in its early stages, it was unstable. Its nucleus appeared fragile, already breaking apart even as astronomers began to study it. This made every observation uncertain. Was the light they measured coming from the solid body itself, or from clouds of dust and ice streaming away into space? The faintness meant that only the most sensitive telescopes could capture usable data. Observatories across the globe coordinated pan-stars in Hawaii, the Hubble Space Telescope in orbit, and numerous ground-based instruments tried to piece together a puzzle that was fading even as it was assembled. Light as messenger, every piece of knowledge came from light. Telescopes do not touch these objects, nor capture samples. They gather photons, reflected sunlight that has traveled across millions of kilometers to strike glass and silicon. Through spectral analysis, astronomers spread this light into its component wavelengths, searching for fingerprints of molecules and minerals. In comets, the fingerprints of water vapor, carbon monoxide, or cyanide can glow faintly in the spectra, betraying their composition. For ATLAs, the signals were ambiguous. Some suggested the release of cometary gases on interstellar body, with frozen volatiles thawing as it approached the sun. Others suggested only dust, a fragile surface crumbling without clear emission lines. The debate lingered. Was Atlas more asteroid or comet? Was it a fragment of rock or a frozen wanderer carrying alien ices? The truth never resolved fully. Its light was too faint, its time too short, its disintegration too rapid. Trajectory. The signature of the alien-if composition was uncertain. Its path was not. The trajectory of Atlas was hyperbolic, unmistakably interstellar. Its orbit curved inward, swept past the sun, and flung outward again toward infinity. The numbers were clear. It was not bound. It would never return. And it carried the speed of a body born elsewhere. Yet even here, anomalies appeared. Unlike ʻOumuamua, which showed unexplained acceleration as if pushed by forces beyond gravity, ATLAS's deviations were less mysterious. They seemed tied to fragmentation, jets of dust and ice altering its course. Still, the data could not capture the full story. The orbit was a record of exile, but the details blurred. Atlas, like the others, refused to fit neatly into categories. The flickering of brightness one of the strangest features of Atlas was its light curved the pattern of brightness over time. Astronomers watched as its glow waxed and waned unpredictably. Sometimes it brightened dramatically, only to dim again. These fluctuations hinted at fragmentation. The nucleus was likely unstable, breaking into pieces under the stress of the sun's heat. Dust and debris scattered outward, temporarily boosting brightness before dispersing. By April 2020, mere months after discovery, Atlas had begun to fall apart visibly, splitting into multiple fragments. It was as if the object had carried its fragility with it across light years, only to unravel before our eyes, an object that would not last for scientists. This disintegration was both gift and loss. A gift because fragmentation revealed details about internal strength and composition. The weakness suggested a loosely bound body, perhaps a rubble pile of dust and ice rather than a solid rock. A loss because it prevented long-term study. By the time instruments were fully mobilized, the object was no longer intact. Atlas denied astronomers the chance for clarity. What might have been a sustained campaign of observation became a race against decay. Each night offered fewer photons, weaker signals, and fading fragments drifting apart in the void. The shadow of ʻOumuamua comparisons arose with ʻOumuamua. That first visitor had been enigmatic. No cometary tail, no clear outgassing, and yet a mysterious acceleration. Some wondered if Atlas might provide the missing context. Was ʻOumuamua a rare anomaly, or part of a spectrum of interstellar bodies? Atlas seemed to tilt toward cometary behavior, with its brightness changes and fragmentation. Yet, the signals remained too faint to confirm beyond doubt. The mystery lingered together. The two objects hinted at diversity, that interstellar wanderers are not one kind, but many. Some may be solid and strange, others fragile and comet-like, each carrying its own story from distant systems, instruments against immensitize its heart. The study of Atlas was a confrontation between human instruments and cosmic immensity. The telescopes were powerful, mirrors stretching meters wide, detectors cooled to near absolute zero, orbiting observatories shielded from Earth's atmosphere. Yet even with all this, the object remained elusive. The immensity was not just physical, but temporal. Atlas had traveled for millions, perhaps billions of years, across interstellar space. Its encounter with our sun lasted only months. Against such scales, human observation is but a flickerer, brief attempt to catch eternity in a net of numbers. Astronomers were humbled. For every photon captured, countless more slipped away. For every signal interpreted, uncertainty remained. The universe had spoken, but only in fragments. The anomalies that haunt them, anomalies of ATLAS, were not as spectacular as ʻOumuamua's unexplained acceleration, but they were unsettling in their own right. Its rapid fragmentation raised questions about its origin. Why so fragile? Was it a fragment of a larger body, already weakened before it entered interstellar space? Or had the journey itself, across unmeasured eons, eroded its cohesion until it arrived as a ruin waiting to collapse? Another anomaly lay in its timing. Why had 3 interstellar objects been seen within just a few years, after centuries of silence? Was this coincidence or evidence that our instruments had only now become sensitive enough to detect what had always been there? The anomalies multiplied not as answers, but as questions. Each one deepened the sense of mystery, of an object that came not to explain, but to remind us of our ignorance. Uncertainty as character in the story of Atlas. Uncertainty itself became a character. Every observation carried caveats. Every interpretation ended with doubt. Astronomers spoke in probabilities, not certainties. Likely a comet, possibly a fragment, perhaps similar to known bodies, perhaps not. But within this uncertainty lay a profound truth. Science advances not by final answers, but by confronting what it cannot yet know. ATLAS embodied that confrontation. It was a reminder that the universe does not reveal itself fully, that its deepest truths are glimpsed only in shadows. Uncertainty is not failure. It is invitation, an invitation to build better instruments, to sharpen our vision, to prepare for the next visitor that will arrive unannounced. Closing reflection 3. Atlas was studied with the full power of human astronomy. Spectra dissected, trajectories mapped, brightness tracked across nights and months. Yet, even with all this, it slipped through our grasp. Its composition remained ambiguous, its origin unknown, its story incomplete. It left behind anomalies, light curves that flickered unpredictably, a nucleus that broke apart, signals that suggested both comet and ruin. It left behind uncertainty, a trail of data that hinted at answers, but dissolved into doubt. And in that uncertainty lies its legacy. For the story of Atlas is not only about what was known, but about what could not be known. It is about the struggle of finite instruments against infinite space, of human eyes straining to read whispers carried across light-years. In the end, ATLAS was more than an object. It was a reminder that the galaxy is filled with wanderers we cannot fully understand, that our tools are still fragile against the immensity of the cosmos, and that mystery is not a flaw in science, but its lifeblood as Atlas disintegrated and vanished back into the night. It left astronomers with more questions than answers. But perhaps that is the point. Perhaps the role of such visitors is not to explain, but to awaken, to remind us that beyond the reach of our telescopes, the universe holds secrets still untold, and in that silence, the next stranger is already on its way. In science, clarity often comes in pairs: a hypothesis, then evidence; a prediction, then its confirmation. But the interstellar visitors that have crossed into our solar system did not bring clarity. Instead, each one carried its own enigma, and together they deepened the mystery. First came ʻOumuamua, a slender fragment with no tail, no coma, and no clear origin, accelerating mysteriously as if propelled by unseen forces. A textbook example of what astronomers expected. And then came Atlas, not asteroid, not comet, not quite either. A hybrid, a ruin, a reminder that the galaxy does not follow human categories, and that the truth may be stranger than either of its predecessors suggested. Between two extremes, ʻOumuamua and Borisov seemed to frame a spectrum. One was alien in its strange, elongated, dark, accelerating without explanation. The other was familiar, almost comforting, its composition nearly identical to solar system comets. Together, they offered a contrast: the inexplicable and the ordinary. Atlas fell in between. It brightened like a comet, its nucleus fragile, shedding dust as it approached the sun. Yet its signals were uncertain, its disintegration incomplete, its story unresolved. It was neither fully cometary like Borisov, nor fully anomalous like ʻOumuamua. It was something else, a fragment straddling both worlds, resisting classification. This ambiguity unsettled astronomers. For if the galaxy produced clear categories, the path forward would be simple. But Atlas suggested something different. It suggested that interstellar space is not populated by neat archetypes, but by a continuum of wreckage, hybrids, shards, broken bodies, each carrying different scars from their origin systems. ʻOumuamua, the anomaly to understand the escalation. One must recall ʻOumuamua. Detected in 2017, it was unlike anything seen before. Its trajectory was hyperbolic, proving it was interstellar. Its shape, inferred from its flickering brightness, was elongated, perhaps cigar-shaped, perhaps disc-like, but undeniably extreme. And then came the anomaly. As it receded from the sun, ʻOumuamua accelerated. A push was there, measurable, undeniable, but no cometary gases could be detected. No tail, no emissions. Nothing that could explain the force. Some scientists suggested exotic hydrogen or nitrogen sublimating invisibly. Others proposed radiation pressure, sunlight itself nudging a thin body like a sail. Still others dared to speculate on technology, though no evidence supported it. ʻOumuamua left questions that remain unanswered. Its strangeness set a tone of cosmic disquiet. Interstellar space was not what we thought. Borisov, the familiar stranger, in 2019. When Borisov entered the solar system, there was relief. At last, an interstellar visitor that behaved as expected. Its tail glowed, its coma expanded, and its spectrum revealed ices familiar to those found in solar system comets. Carbon monoxide and cyanogen were detected, matching the chemistry of our own Oort cloud. It was proof that comets elsewhere follow similar patterns. Planetary formation, at least in chemistry, might be universal. Borisov was strange only in its speed and origin, not in its behavior. For a moment, it seemed the galaxy might be comprehensible. One anomalous fragment, one familiar comet perhaps, ʻOumuamua, was the outlier, a rare eccentric, while Borisov represented the norm. But then came Atlas, the hybrid discovered in late 2019. 3.1 ATLAS should have clarified the debate. Instead, it blurred it. Its brightness increased like a comet. Its nucleus fragmented, scattering dust. Yet, its spectrum was faint, its emissions ambiguous. It seemed comet-like, but without the clarity of Borisov. Its disintegration was dramatic, yet the details resisted firm categorization. ATLAS was not wholly comet, nor wholly asteroid. It was a hybrid, a liminal body straddling two identities, neither one nor the other. In this ambiguity lay escalation, for it suggested that the galaxy may not provide clean archetypes. Instead, it hinted at diversity beyond expectation, countless interstellar objects, each unique, each carrying its own scars of origin. Cosmic hybrids and shards. The implication was profound. If ʻOumuamua represented the anomalous extreme and Borisov the familiar, then Atlas represented the continuum between them. Perhaps the interstellar medium is filled not with copies of our comets, but with hybrids, bodies partly icy, partly rocky, weakened by eons, fragmented by collisions, eroded by cosmic rays. Perhaps the objects we detect are only survivors of countless processes, planetary ejection, stellar tides, or ancient impacts. In this vision, the galaxy is not neat. It is filled with shards, splinters of planetary systems torn apart, fragments without category. The cosmos becomes a sea of ruins, and each visitor is not a representative of its kind, but a unique exile with no twin billions. In the dark, the escalation did not stop at ambiguity. It extended into numbers. 3 interstellar objects in only a few years meant one thing: the galaxy is teeming with them. Simulations confirmed it. Trillions may drift through the Milky Way. Billions may cross the solar system unnoticed, too faint to see. If Atlas was a hybrid, a ruin, then countless others must exist, objects broken, ambiguous, defying human categories. They are the cosmic wreckage of alien systems, drifting silently, carrying within them the stories of their violent births. And this is the terrifying scale of escalation. It is not that one fragment was strange, but that billions more may be stranger still. A universe of ruins. What Atlas revealed was not simply an object, but a truth about the galaxy. The Milky Way is not serene. It is violent. It scatters the ruins of its systems across the void. Gas giants fling comets outward. Collisions shatter asteroids. Tidal forces near stars tear planets apart. The remnants of these catastrophes do not vanish. They drift, preserved in exile, crossing space for millions or billions of years. Atlas was one such ruin. ʻOumuamua and Borisov. Each fragment was testimony. Together they spoke of a galaxy filled with the wreckage of alien histories, and the more that are seen, the clearer the message. Our solar system is not alone, not protected. It is immersed in a sea of ruins, a crossroads of exile. The philosophical weight, the escalation of the mystery, was not only scientific, it was existential. For if the galaxy is filled with ruins, then permanence is illusion. Planetary systems are fragile, temporary, destined to scatter their fragments. Earth and its companions are not exempt. One day, whether through collision or instability, the solar system too will cast its remnants into the void. Pieces of Earth may drift one day as interstellar objects, exiles wandering alien skies. In this reflection lies both terror and humility. Terror, because it shows the fragility of worlds. Humility, because it reminds us that Earth is not unique. We are part of a galactic story of creation and destruction, of scattering and exile. Atlas deepened this reflection. Its ambiguity reminded us that categories fail in the face of cosmic diversity. Its scale reminded us that ruins are vast, dangerous, and countless. Its fate reminded us that fragility is universal. Escalation without end. ʻOumuamua raised questions. Borisov provided answers. Atlas unraveled them again. The pattern is not of clarity, but of escalation. Each new visitor deepens the mystery, complicates the picture, widens the gap between what is known and what is unknown. This is the essence of escalation. Knowledge does not resolve. It multiplies questions. Each answer carries its own anomaly. Each visitor proves not that we understand the galaxy, but that we have only begun to glimpse its diversity. In Atlas, the escalation was complete. The galaxy is not neat. It is not comprehensible by a handful of categories. It is a sea of ruins, hybrids, and shards, drifting endlessly, crossing our path by chance. Closing reflection. 3i. Atlas escalated the mystery of interstellar visitors. Between ʻOumuamua's strangeness and Borisov's familiarity, it stood as a hybrid, a fragment that resisted classification. Its ambiguity suggested a galaxy filled not with archetypes, but with diversity beyond imagination. It deepened the scale of terror, reminding us that billions of such objects must exist, drifting unseen wreckage from systems long destroyed. It showed that the universe is not serene, but violent, scattering its ruins across light years, and in its presence lay a reflection that worlds are fragile, that permanence is illusion, that our solar system too is temporary, and one day may scatter its own fragments across alien skies. Atlas was not only a visitor, it was escalation itself, a reminder that each new discovery does not close the mystery, but deepens it, a whisper that the galaxy is stranger than we can imagine, and that the true scale of interstellar ruins has only begun to be revealed. For in the silence between stars, billions of strangers are waiting, drifting, unseen. The fragments of interstellar debris that wander into our solar system are more than curiosities. They are questions carved in stone and ice, drifting for eons before briefly crossing human sight. Each one forces astronomers to ask, where did this body come from? What events flung it into the abyss? And what larger truth does it carry about the galaxy itself? Theories abound, born from data, refined by mathematics, and expanded by imagination. Some are grounded in planetary dynamics, others in stellar violence, and still others in the most profound question of all, the possibility of life carried across the stars. 3IATLAS. Like its predecessors, ʻOumuamua and Borisov became a canvas for speculation. In its fragility, its ambiguous nature, and its fleeting visit, it whispered of origins that could not be directly seen. Yet, through comparison, analogy, and theory, astronomers began to map possibilities. 1. Planetary ejection. The violence of birth stars are born in clouds of gas and dust. Around them, disks of matter swirl, colliding, coalescing, giving rise to planets, moons, asteroids, and comets. This process is not gentle. It is violent, chaotic, filled with collisions and near-dash misses. Their gravity reshapes the orbits of smaller bodies, scattering some inward to form asteroid belts, flinging others outward toward interstellar night. Simulations suggest that Jupiter itself may have ejected trillions of icy fragments during the early history of the solar system, scattering them into exile. If this is true for our sun, then it must be true for others. Every star with gas giants may be flinging debris outward, even now. ʻOumuamua, Borisov, and Atlas could simply be representatives of this galactic diaspora, objects born in disks, shaped by giants, and exiled into infinity. The planetary ejection theory is compelling because it explains numbers. If every star scatters debris, then the galaxy should indeed be teeming with fragments. What humanity has glimpsed 3 visitors in just a few years could be only the faintest surface of an unimaginable sea. But the violence of planetary ejection carries a deeper reflection. It means that every interstellar object is not just stone or ice, but history, a remnant of a planetary system's creation, a shard of worlds that may or may not have formed. Each exile is the echo of a birth. 2. Stellar catastrophes. The scars of death. Fifth, planetary ejection explains birth. Another theory points to death. Stars do not live forever. Some die quietly, swelling into red giants before shedding their outer layers. Others end in cataclysm, supernova explosions so powerful that entire planets may be destroyed or flung outward. Such stellar catastrophes could scatter fragments into stellar space, a planet's crust ripped apart by tidal forces, an asteroid belt disrupted by a star's collapse. Even planetary cores, stripped of their atmospheres and mantles, wandering as naked survivors of apocalypse. Could Atlas have been one of these? Its fragility hinted at ruin. Its disintegration suggested a body already weakened, perhaps battered by radiation or shattered. Long before it reached our sun, some speculated it could have been a fragment of a larger body torn apart by stellar violence. The terrifying implication is that interstellar objects are not only relics of creation, but also of destruction. They are tombstones of stars, drifting reminders that death is as common as birth in the galaxy. Each fragment may be a scar, bearing silent testimony to a system that no longer exists. And among these ruins, some may be massive. Imagine the stripped core of a planet, wandering endlessly, larger than any asteroid, harder than any comet, moving at galactic speeds. To encounter such a body would be to confront the ghost of a world preserved only in exile. 3. Cometary reservoirs. Alien Oort, clouds far beyond Neptune. The solar system holds a shadowy domain, the Oort cloud. a vast reservoir of icy bodies extending almost halfway to the nearest stars. Though never observed directly, its presence is inferred from the long-period comets that occasionally plunge toward the inner planets. If the Sun has such a reservoir, then surely other stars do as well. And just as nearby stars tug at our Oort cloud, so too might stars disturb one another's reservoirs. Gravitational nudges could eject trillions of comets from these distant shells, sending them drifting through interstellar space. In this view, ʻOumuamua, Borisov, and Atlas may simply be emissaries of alien Oort clouds, fragments that once orbited distant suns, nudged loose by passing stars or galactic tides. Their composition icy, dusty, fragile, fit the mold of comets. This theory suggests not only abundance, but inevitability. For if every star holds a vast Oort cloud, then interstellar space must be alive with exiled comets, billions of icy messengers, most too faint to see, passing silently through the dark. The thought is humbling, for in each of those icy shards may lie the chemistry of distant systems, frozen molecules from alien cradles of planets. They are reservoirs not only of matter, but of history, for carriers of organic molecules, seeds of panspermia. Among the most provocative theories is that interstellar objects may not only be ruins, but couriers of chemistry, and perhaps of life itself. In the icy interiors of comets, complex molecules can form. Amino acids, sugars, even the precursors of RNA have been detected in meteorites and comets within our own system. If such molecules exist here, why not elsewhere? An interstellar comet, born in the disk of another star, could carry these molecules across light years. And if it collided with a young planet, it could deliver seeds, organic compounds that may help life begin. This idea, known as panspermia, has lingered for centuries, from ancient philosophers to modern astrobiologists. While speculative, it cannot be dismissed, for interstellar debris is real, and organic chemistry is universal. Could Atlas have carried such molecules? Its fragility suggested ice. Its comet-like brightening suggested volatile material. Within its body, frozen long before humans walked the earth, may have been molecules formed in another system, preserved for millions of years. If true, then each interstellar visitor is not only a fragment of stone, but a messenger of possibility. The seeds of life drifting freely through the galaxy, scattering across worlds, connecting biospheres that may never know of one another. 5. The planetary core hypothesis, survivors of cataclysm. The more chilling possibilities is that some interstellar objects are not comets or asteroids at all, but planetary cores, survivors of cataclysms so extreme that entire planets are stripped, leaving behind only dense remnants. Such remnants would be strange, metallic, massive, unyielding. They would not fragment like ATLAs, nor sublimate like Borisov. They would be hard, silent, and deadly. If even a fraction of interstellar debris consists of such cores, the implications are terrifying, for these are not harmless comets, but bullets of iron and rock, moving with galactic velocity. Should one intersect Earth's path, the devastation would be beyond comprehension. The planetary core hypothesis is speculative, but rooted in real physics. Collisions in young systems can strip planets. Tidal forces near stars can tear worlds apart. Some remnants must survive, flung outward as silent ghosts of destroyed worlds, and if they wander through space, they too may pass through our solar system, unseen until too late. Diversity beyond imagination. What unites all these theories is the recognition that interstellar debris is diverse. Some may be icy fragments from alien Oort clouds, others rocky shards ejected by giants, still others scarred remnants of stellar death or even planetary core. ʻOumuamua, Borisov, and Atlas may represent this diversity, each one different, each one strange, each one resisting full understanding. And if three can be so distinct, then billions more may exist with properties beyond imagination. The galaxy, then, is not uniform. It is a patchwork of histories, each system scattering its fragments, each fragment carrying its own story. The terrifying abundance, the most unsettling speculation, lies not in origin, but in scale. If planetary ejection, stellar death, and cometary reservoirs are all sources of interstellar debris, then the galaxy must be filled with it. Trillions of objects crossing interstellar space endlessly, most never detected. Billions may drift unseen through our own solar system every year. Most are pebbles, dust, too faint to matter. But some, like ATLAs, are mountains, and among them, some may be deadly planetary remnants, large enough to rewrite the history of any world they strike. The terrifying truth is not only that these bodies exist, but that they are countless. The galaxy is not empty. It is alive with ruins, philosophical reflection, messengers of creation and destruction in the end. The theories are not only scientific, they are philosophical. For if interstellar debris carries molecules of life, then the galaxy may be a single, connected ecosystem. Worlds may not be isolated, but linked through chemistry, each one both recipient and donor in a cosmic exchange. If debris carries only ruin, then it is a reminder of fragility, that planetary systems are temporary, their remnants scattered across eternity. Perhaps both are true. Perhaps each interstellar visitor is both messenger of possibility and reminder of destruction. Atlas, in its fragile disintegration, embodied this duality. It carried the brightness of a comet, the ambiguity of a hybrid, the possibility of molecules from another world. Yet it also carried the shadow of catastrophe, the evidence of systems torn apart. In its passing, humanity glimpsed not only science, but philosophy. For Atlas was not just a fragment. It was a mirror reflecting the violence of the galaxy, the possibility of life beyond Earth, and the fragility of our own place in the cosmos. Closing reflection theories and speculations swirl around every interstellar object. Planetary ejection, stellar catastrophe, cometary reservoirs, panspermia, planetary corsets. Possibility adds depth to the mystery. None are confirmed. All are plausible. Together, they sketch a picture of a galaxy restless, violent, and alive with fragments. In Atlas, these theories converge. It could have been a comet from an alien Oort cloud, ejected by a distant star. It could have been a fragment of a larger body, destroyed in stellar violence. It could even have carried molecules formed in another system, drifting as seeds across the void. its ambiguity left no final answer. But in that ambiguity lay meaning. The galaxy is not simple. It is diverse, violent, creative, destructive. It scatters its fragments freely, and each fragment carries whispers of truth. And so, the story of ATLAS is not closed. It is open, as wide as the galaxy itself. A reminder that the mysteries of interstellar space are not solved by a single theory, but deepened by them. A reminder that the galaxy is both terrifying and beautiful, filled with ruins, filled with seeds, filled with stories that drift silently across the stars. In every fragment lies a question. In every exile lies a truth. And in Atlas, humanity glimpsed both creation and destruction, bound together in silence. In the end, the interstellar visitors that have crossed our sky are more than stones. They are messages. Messages written not in words, but in silence. Not in ink, but in trajectories carved across the solar system. Each one arrives unannounced, travels briefly under the warmth of the sun, and then vanishes again into the darkness. ʻOumuamua, Borisov, Atlas, 3 fragments from 3 unknown places, 3 stories without beginnings or ends. Together, they leave humanity not with answers, but with reflection. They remind us of a truth as old as the stars, that the universe is violent, messengers of violence. Every fragment is evidence of upheaval. ʻOumuamua may have been torn from a larger body, flung outward by the shifting gravity of giants. Borisov may have been ejected from the frozen reservoir of another star, a comet ripped from its long exile. Atlas may have been the ruin of a larger body, already fragile before it reached our sun, breaking apart under its final heat. Each one testifies to systems in turmoil, planetary disks scattering debris, stars casting away their children, collisions tearing worlds apart. The galaxy is not serene, not orderly. It is restless. It builds, destroys, and scatters. When Atlas disintegrated before our eyes, it carried a mirror to our own fate. For one day, our system too may fall into instability. Earth itself may be shattered, its fragments cast outward, drifting for eons before crossing the sky of another world. These visitors are warnings, reminders that permanence is illusion, that even worlds can be lost, messengers of kinship, and yet, within their silence, another truth lingers. For in their icy interiors, comets can harbor complex molecules, amino acids, sugars, the raw materials of life. If such molecules can form here, they can form elsewhere. And if they can form elsewhere, they can travel. An interstellar fragment striking a young planet may not only scar it may seed it. Molecules carried across light years may survive impact, embedding themselves in alien soils, igniting chemistry that leads to biology. This is the idea of panspermia, once only speculation, now made plausible by the reality of interstellar visitors. For ʻOumuamua, Borisov, and ATLAS are proof that fragments do travel between stars. The journey is real. The courier exists. The possibility is alive. If so, then life itself may not be confined. It may be scattered as freely as dust. It may not be an isolated miracle, but a galactic inheritance shared across systems, carried in fragments, spread across time. In this reflection, the visitors are not only warnings, they are kinship. They remind us that we may not be alone, not even in the silence of interstellar night. Humanity at the shore end. Humanity stands at a threshold. We are young, still bound to one star, still learning the language of the sky. But the visitors remind us that we are not apart from the galaxy. We are immersed within it. Our solar system is not an island, but a shore. And upon this shore, fragments from alien beaches wash up, carrying whispers of places we will never see. ʻOumuamua was the first wave, small and strange. Borisov was the second, familiar yet alien. Atlas was the third, large, fragile, and haunting. Each one a stone placed at our feet, carried across the galactic ocean, delivered by tides we cannot yet measure. We do not know when the next will come. Perhaps years, perhaps centuries, but it will come. Another stone from another shore, another whisper across eternity. Terror and beauty, there is terror in this, for the stones are not harmless. Some are mountains, some are bullets. All move with velocities beyond human defense. To imagine one striking Earth is to imagine extinction. To imagine one passing too close is to imagine chaos. But there is beauty as well, for these fragments connect us. They remind us that we share in the galaxy's story, not only in its destruction, but in its creation. We, too, are fragments, born of star death, scattered atoms fused in ancient suns. The stones from alien systems are not strangers. They are kin. They are reminders that the elements of Earth and the fragments of Atlas share the same heritage, born in stars, scattered in violence, preserved in silence. In them, we see both fragility and belonging. Closing reflection. ʻOumuamua slipped away, still unexplained. Borisov glowed and vanished, leaving chemistry familiar yet alien. Atlas fragmented, fading into dust, its secrets half. Each one was fleeting. Each one left silence. But in that silence lies a truth humanity cannot ignore. That the galaxy is filled with ruins, that life may travel in ways unseen, that we are part of a current larger than ourselves, a river of fragments crossing eternity. Humanity now stands at the edge of that river. We cannot yet cross it. We cannot yet follow where the stones return, but we can listen, we can watch, and we can reflect. For when we look upward and see the sky, we are not staring into emptiness. We are staring into an ocean filled with fragments, each one a message, each one a reminder, a terrifying, beautiful reminder that we are not alone, not even in the silence of interstellar night.